Has your car lost power, started using more gas, shaking at idle, or accelerating like it's choking? A lot of people replace spark plugs, ignition coils, the fuel pump, or even sensors that have nothing to do with the problem. But there is one part that can completely fool the engine computer: the MAF sensor. The MAF sensor measures the amount of air entering the engine. With that information, the computer calculates how much fuel needs to be injected. If the MAF sensor sends the wrong signal, the computer can make the air-fuel mixture too rich or too lean, causing problems that may look like they are coming from other systems. When the MAF sensor fails, one of the most common symptoms is loss of power. The engine may feel heavy, slow to respond, or weak when you press the gas pedal. You may also notice hesitation, jerking, rough acceleration, or a lack of power when going uphill. Another symptom is an unstable idle. The engine may shake, the RPMs may go up and down, the vehicle may stall when coming to a stop, or it may struggle to stay running. In some cases, the engine starts and then shuts off almost immediately. Excessive fuel consumption is another common sign. If the MAF sensor reports more air than what is actually entering the engine, the computer injects more fuel than necessary. This can cause a strong fuel smell, black smoke from the exhaust, carbon-fouled spark plugs, and poor fuel economy. If the MAF sensor reports less air than what is actually entering the engine, the mixture can become too lean. In that case, the engine may experience knocking, lack of power, overheating, hesitation, and lean condition trouble codes. The most common codes related to the MAF sensor are P0100, P0101, P0102, P0103, and P0104. But be careful, just because you have a MAF sensor code does not automatically mean the sensor is bad. The problem could also be unmetered air, a clogged air filter, damaged wiring, a bad ground, or a power supply issue. The first test is a visual inspection. Check that the air filter is not dirty, damaged, or incorrectly installed. Make sure there are no loose hoses, air leaks after the MAF sensor, loose clamps, or cracked intake ducts. Any air leak after the MAF sensor allows air to enter the engine without being measured by the computer. Next, inspect the connector. Look for loose pins, corrosion, broken terminals, or damaged wires. Many MAF sensor problems are not caused by the sensor itself, but by a bad connection or a poor ground. The next test is with a scan tool. In live data, look for the MAF sensor reading in grams per second. At idle, a small engine may normally read between 2 and 7 grams per second, depending on the engine. When you accelerate, the reading should increase quickly and smoothly. If the reading stays fixed, suddenly drops, shows 0, or changes irregularly, there is a problem. Another practical test is to disconnect the MAF sensor with the engine off, then start the vehicle. On many cars, when the MAF sensor is disconnected, the computer uses default values. If the engine clearly runs better with the MAF sensor unplugged, that is a strong clue that the sensor may be dirty, damaged, or sending an incorrect signal. But this test is not definitive, it is only a guide. Now let's move to the electrical test. Many MAF sensors have a power wire, a ground wire, and a signal wire. Some work with 12 volts, others with 5 volts, and some have additional wires because they also include the intake air temperature sensor. With the key on, measure the power supply. You should have the correct voltage according to the vehicle system. Then check the ground. A bad ground can make the MAF sensor send a false signal. After that, measure the output signal. On analog MAF sensors, the signal is usually around 0.5 to 1 volt at idle, and it should increase smoothly as you accelerate. There should be no jumps, cuts, or sudden voltage drops. On some sensors, the signal is not an analog voltage signal. It may be a frequency signal. In that case, you'll need a scan tool, a multimeter with frequency function, or an oscilloscope. A very useful way to test it is to remove the MAF sensor from the intake duct, leave it electrically connected, and measure the output signal. With the key on, identify the signal wire and connect the multimeter between the signal wire and ground. Now, gently blow air through the sensor's air passage. The signal should change. If you blow through the sensor and the signal does not change, stays frozen, or reacts suddenly and irregularly, the sensor may be damaged. Do this test carefully. Do not touch the internal wire, filament, or resistor inside the sensor. Do not use high-pressure air. Do not insert objects, and do not clean it with carburetor cleaner. If the sensor is dirty, use only MAF sensor cleaner and let it dry completely before reinstalling it. Another professional test is using an oscilloscope. The MAF sensor signal should look clean, stable, and progressive. When you accelerate or move air through the sensor, the signal should rise without dropouts. If the signal cuts out, has excessive noise, or disappears, check the power supply, ground, and wiring before condemning the sensor. You can also perform a light tap test. With the engine running, gently move the connector and wiring harness. If the engine starts to misfire, stalls, or the reading changes suddenly, the problem may be in the wiring, not necessarily in the MAF sensor. Another important test is comparing the MAF sensor reading with engine RPM and engine load. If you accelerate and the reading barely increases, the sensor may be dirty or damaged. But it could also be a restricted exhaust, low fuel pressure, or an intake restriction, which is why you should never replace the sensor without checking the complete system. If this video helped you understand how to test a MAF sensor like a professional, subscribe to the channel, turn on the notification bell, and let me know in the comments what problem your car is having. In the next video, we'll keep diagnosing real engine sensors and real engine problems step by step.